Before spring break, we were talking about multiplying polynomials. And we were doing this using algebra tiles. So we were multiplying things like x plus 1 times x plus 6. So every rectangle we had was an x, and every little square we had was a 1. Okay, so here's our x plus 1, and here's our x, and then we have 6 right here, right? Plus 1, all the way through. Then we actually multiplied these to get this area inside. So x times x is x squared. Then when we did x times 1, that's just 1x. So then going to the other side, we have x times 1, which is just x. So all of these are just an x. And then we have 1 times 1, which is just 1. Then we said if we add all of this together, that tells us the entire area, kind of like the product. So we have x squared. Now we have all of these alike terms. These are all x. How many are there? There are 7. So we have 7x. And then like terms, all of these 1s, and there are 6. So we get x squared plus 7x plus 6 as the product. Now, we don't have algebra tiles, most likely at home. And really in the class, we want to use them every day. So how can we do the same idea without algebra tiles? Well, it's something called the box method. You're creating a box. And the box is going to look very similar to the one that's set up when we use the algebra tiles. Alright. So, one length of our box is the first value that's being multiplied, or the first polynomial. And then the other side of the box is the length of the other polynomial. So we have a monomial, one term, multiplied by 2 terms. So I'm going to create a box that is 1 by 2. So 6p, and then 5p minus 2. So, to find this first box, what is 5p times 6p? Well, that is 30p squared. And in the next box, we have negative 2 times 6p. It's negative 12p. Now, these are not like terms, because one is p squared and one is not. So this becomes 30p squared minus 12p. It's the same thing as just distributing the 6p to each of those terms. So in our next example, we have a monomial times a trinomial, 3 terms. So to set up our box, we're going to have 3, and then we're going to have 3 terms, so I got to split this up into 3 parts. 7v squared, a positive 7v, and a positive 3. So 7v squared times 3, 21v squared. 3 times 7v, 21v. And 3 times 3 is 9. Again, none of these are like terms, so we get 21v squared plus 21v plus 9. Now, what if we have a binomial times something? So no more single-term polynomials. So in this case, 6x plus 3 times 5x minus 3. So we have 2 terms times 2 terms. So our box is going to be a 2 by 2. So we have 2 rows, 2 columns. So we have 6x plus 3 and 5x minus 3. So now to find the inside, 6x times 5x is 30x squared, and 6x times negative 3 is negative 18x. 5x times 3 is 15x, and 3 times negative 3 is negative 9. Now in this situation, we do have like terms, negative 18x and 15x. So when we add these together, we're going to have to combine the like terms. So we have 30x squared, and then negative 18x plus 15x is negative 3x, and then our minus 9. So there's our product. Now in this next example, we have a binomial, 2 terms, times a trinomial, 3 terms. So we're going to have a 2 by 3 box. So we have 2 rows and 3 columns. So 7n minus 6, and then 4n squared plus 5n plus 3. So 7n times 4n squared is 28. N cubed to the 3rd power, because we have n squared and an n. So remember, this is like a 1 right here. 5n times 7n is 35n squared, and 7n times 3 is 21n. Now 4n squared times negative 6, negative 24n squared. Negative 6 times 5n is negative 30n, and negative 6 times 3 is negative 18. Now this time we have 2 sets of like terms. We have 35n squared and negative 24n squared, along with 21n and negative 30n. So 28n cubed. Now to combine like terms, 34n squared minus 24n squared. It's a positive 11n squared. And then negative 30n plus 21n gives us a negative 9n, and then minus 18. So the size of your box just depends on the number of terms you have in each of the polynomials you're multiplying together. Now this is a nice way to organize all of our work. You can do this without the box, and I can show you examples of that. It's really just using the distributive property. So when it's just a monomial times other polynomials, that one's pretty simple. We've done cases like that at the beginning of our algebra class. When it gets interesting is when you're multiplying by more than one term to the entire polynomial. You have to make sure and distribute each term in the first polynomial to every term in the second one. So in this case, 8p times 6p, 48p squared, and 8p times 4, 32p. Then we need to continue and do 2 times 6p, which gives us 12p, and 2 times 4, which gives us 8. Now we look for our like terms and combine them. This is the same product as if you were doing the box. So here to illustrate that, 8p plus 2, 6p plus 4. We're getting the same terms as we did before. These are the same. Just the box is a way to organize it so I know I'm multiplying all the right pieces together. So if you want to do the distributive property, you may, but I highly encourage you to do this box method, as it is going to come in handy and will be utilized in future lessons.